Hi, it's me again. This should be the last video for me for the week. You'll see me in person on Thursday, and I know some of you guys have been working hard, and I super appreciate it. And know some of you guys have been struggling, and you've been emailing me, doing the work. Awesome. Today, when you watch this video, please work together. Try to work with somebody next to you so that you all know what the answers are. Um, that's not the goal, just to know what the answers are, but to have a question. Like if you think the answer's 5 and the person next to you says it's 6, talk about it, please. Um, that's what I try to encourage you to do when we're in class, and that's what I want you to do in this video. That's the idea of it. So let's do this. Thank you for participating, and you have quizzes tomorrow in Khan Academy. You show up to class and they will show up as assignments, and good luck. Okay, so today's video has a worksheet that you'll need towards the end of it. Sorry, all my controls are right here at the bottom of my screen, so that's what I'm doing right now. You'll get that video. There'll be a place in the video that'll say make sure you get the worksheet, if your teacher has not already given you the worksheet. So today we are looking at what we have been looking at for the time that we've been together. 2 weeks I was with you, 1 week I wasn't, and now this is the 4th week, but our goal has been to study linear functions before we move on to the true Algebra 2 content. So what I've covered so far you should have seen in Algebra 1, and if you had questions or struggled with it, hopefully this has given you time to remember it, revisit it, get more help on it. So the first thing I introduced about lines was when we started solving, and I introduced the variable y. And then I gave you this form to help us graph. So y equals mx plus b is one way to write the equation of a line. It's a common way that you'll see that the line's written. And the other thing I wanted you to think about are the solutions, that they're inputs and outputs. You can organize them in a table. And if you do input x equals 1 into the equation, you work the math out, you get a y value. And if you change the x, you're going to keep getting different y's. And that if you sub in x1, x2, x3 in order, that the y values show a pattern, whether they are increasing or decreasing, that pattern is what number is in front of the x in the equation, and that's referred to as the slope of a line. This is why they call it slope-intercept, because you see the slope, and the intercept is not that easy to see. So 5 subtract 3 is 2, 10 subtract 3 is 7, 15 subtract 3 is 12. So 5 times the x, take away 3, you're going to see the y values increase by 5 every time. Now, the y-intercept is why they call it slope-intercept. They should probably start calling it slope-y-intercept so that people can remember that there are 2 intercepts, and this one back here is the y-intercept. This is the variable y, and this equation can read y equals b if this mx chunk were gone. And the y-intercept is the point where the line intersects the y-axis. And so you have visuals. I think something in Khan Academy was asking for you to identify intercepts from a graph. So this right here is the y-intercept of 0, -2. This is the intercept 0, 1. And so when I ask you for the y-intercept, I don't want you to just give me this naked number back there, because it's a point. And the equation has an x and it has a y. And so the y-intercept is only that number if you let the x be 0, right? In the previous example, this -3 did not appear as the y because I didn't show the x was 0. So again, they call it a slope-intercept, and this is the y-intercept, and it's what y is equal to if the x is equal to 0. So the equation for the y-axis is x equals 0. That's the equation for the y-axis, and it's all the points where the x is 0, but the y could be anything. So when you see an equation of a line, you start studying lines and realizing that this 4 is this 4 on the y-axis. It's not this 4 over here. Because it's not x, it's y, and it's y when the x is 0. So reading this form and knowing these two pieces of information are things that we did practice. I'm going to ask you to do a couple of questions here. So I'm asking, what's the slope? The slope is rise over run, and then what's the y-intercept? Please talk to each other. And another quick check. Here's the graph, but you don't need the graph to answer the question, what's the slope and intercept, from an equation that's written in y-intercept form. So the worksheet you're going to do today is called Changing Forms, because slope-intercept is not the only form of the equation of a line. This is the same line that I'm showing from the previous slide on this slide that says standard form. And the standard form of an equation has x and y, linear equation, has both x and y, but the x and the y are written on one side of the equation, and the constant value, the value that doesn't have a letter attached to it, is written on the other side of the equation. So this is the standard form for this line. It's the same exact line from the previous slide, but you see that the form is different. There's some commonality. So you see like there's 2's and 3's, and when you see this equation, there's 2's and 3's, but there's also this crazy 6 right here. So the 6 is not shown on the graph. I mean, you know, there's a 6 on the graph. There's x equals 6, there's y equals 6, not on this snapshot, but what you do see are the intercepts here. The x-intercept is 2, 0, and then the y-intercept is 0, 3. And so those are the things that I was doing in the yesterday's video, I think the video from last week as well, where I was letting x be 0, solving for y, letting y be 0 and solving for x. But if you look at this number 3 and this yellow x, you see what the x-intercept ended up being was 2. And 3 times 2 makes that 6. So when it's written in this form, and this constant value can be divided evenly by the a and the b, it's not a lot of pencil paperwork to try to figure out what the x and the y intercepts are. And I'm trying to give you the ones that are easy to do in your head, just to get the concept of x-intercepts are when the y is 0, and the y-intercept is when the x is 0. So you see the reason why this 2 with the 0 would make sense is because 3 times 2 all by itself makes 6. And I can't say that 3x is by itself unless the y were gone. And the way to make y be gone is to multiply it or let it equal 0. And then in that part of the equation, it's not relevant anymore. If you add 0, it's like adding nothing. So if I put a 0 in the x position, I'm just solving 2y equals 6. And so I want you to try to do these in your head with the knowledge that intercepts are easily divided sometimes. And when they are, I want you to try to do them in your head. Okay, so look at just 3x equals 6 3 goes into 6 twice, 2, 0. That's the x-intercept. 2y equals 6. 2 goes into 6 evenly 3 times, 0, 3 is the y-intercept. This problem, if I just look at the x part of the standard form, negative 2x, if I divide it into the 4, there's one negative, one positive. That's why the x stays negative. But if I have negative 2x plus y equals 4 and I get rid of this little x part, it just says y equals 4, and that's what the y-intercept is. Again, that was a lot of me talking. I didn't write anything down, but I'm hoping that you'll try to get, I don't want to say get answers, but double check with the people around you before you input your next answers. So this question, first question, what's the x-intercept? Second question, what's the y-intercept? Another example. What's the x-intercept? Again, what do I have to put in place of x to solve 5 times x equals 30? Next question, what's the y-intercept? The y-intercept is going to have a negative y because a negative times negative makes positive. So think, what number times negative 3 makes positive 30? Oh, I got one more. So for the rest of the video, I want you to work on completing this worksheet. I'm going to do 6 of the 10 questions, and then I want you to finish the rest of it in class, submit it. With any time that you have left over, please work on the EdPuzzles if you haven't completed those. Work on Khan Academy, send me an email, tell me that you finished it. But for right now, I am going to ask that you turn in this page before you leave. So I'm going to do the first few problems with you, the first 6, and then hopefully you can work with a partner, or I've done enough that can help you with finishing it on your own. So the first thing I want you to do is to try to change this into slope-intercept form. And you haven't seen that yet in the video, but I do want you to show your steps. And when I change an equation into slope-intercept, what I'm trying to do is isolate the y on one side, and the x's and the constant are together on the other side. So on this worksheet, I've made them all standard form equations, and so the steps to getting the y isolated will be the same. So the first step is to subtract this variable onto the other side, and that's when you're doing the opposite. I say subtract, but if it were a negative x, I would be adding it. And when I do get it over to the other side, the way you arrange it doesn't matter. You can do negative x plus 6. Sometimes I see students just write what was originally there and then the operation on the x because the signs are a little weird. But you're not actually subtracting anything. Now you just have 2 things over on the right side, and that chunk with the y is all by itself. So what I just did was I subtracted x on both sides. Now I could find the intercepts without doing this, but the point of this worksheet is to get you to move from standard form into slope-intercept. Practice graphing, practice the vocabulary, but this is what I want to see that you know how to do. The next thing to isolate the y, again, I'm not moving the y, I'm just getting rid of everything on that side, is I have to cancel this negative 2, and it's glued to the y. And so I'm going to use division, and you won't see me using opposite signs, but I am using an opposite operation. So instead of multiplication, I'm dividing. And you also see me dividing both parts by -2. This will slice the coefficient off of the y, and it's getting it into this form that I'm looking for. This is divide, right? And so positive divided by negative stays negative. This is also divide, but you can't actually divide it. If there was any number in front of x, it's 1. When it's not there, when it's not written there, it's 1. And a negative divided by a negative is a positive. So that is the trickiest part of changing form from into slope-intercept form, is when you have to divide that number off the y. So in this form, what I can see pretty clearly is the slope of the line is the 1/2. I also want you to write the y-intercept as a coordinate point, so 0, -3. And I said mxb, but this is like b plus mx, right? But it doesn't matter. You know, whatever is multiplied to the x is the slope. It doesn't matter if the slope is written in front. And then the x-intercept, well, I'm just going to go back to the original form, which was x minus 2y equals 6. And basically, when the y is 0, that piece of the equation can allow me to do this part in my head. 6, 0 is the x-intercept. So if I was graphing this based off of x and y intercepts, I would just go 1, 2, 3, 4, 5, 6. And then the y-intercept is 1, 2, 3, like that. And then I would take a ruler, connect the dots. But if I was using slope-intercept, I would start at 0, -3, and then I'd go up 1 and over 2, up 1 and over 2. So even though, like I said in yesterday's video, I want you to know how to do everything, that was the goal of this class, was for a couple of weeks, now stretched into 4. I was, you know, I was asked to go through linear functions with you. So that's it. Number 1, I'm going to do, like I said, 6 of them with you, ask you little questions along the way, and then hopefully you can finish this, turn it in before you go. So the first step of this one is I would subtract 4x from both sides, and both sides of that equal sign right there. It would cancel this, and then I still have the positive 2. I'm not putting the plus, but on the other side, again, if you're more comfortable writing it like this instead, doesn't matter what's in front. What matters is the symbol on the x. Is negative, it's still a negative x. The 8 didn't have that big plus sign in front of it, but if there's no negative in front of it, it is a positive 8. So then I move to the dividing, and when I divide both sides, meaning both things on that side. This will divide, and more so like you feel like you're canceling it. And then this part right here, you're dividing. -4 divided by 2 is -2. 1 negative divided by positive stays negative. And then this 8 divided by 2 is going to give me a 4. And so you can choose to graph it however you want. If I knew slope-intercept form, 1, 2, 3, 4, and then down to over 1, down to over 1, down to over 1. From slope-intercept form, I could tell that the slope is -2. I can also tell that the y-intercept is 0, 4, and the x-intercept is going to be when I let the y be 0. So excuse me, that's a lot easier when I look at the original form. And I just I let the y be 0, so it's like I cross that out, and then I divide. 4 goes into 8 twice. And then you also see that right here, right? I said I was going to do 6 of them, but I just feel like hopefully you're getting it. So I'll do 2 more. I wish we were in person so I can get a good read. But I also want you to be able to do some of this on your own. And these videos, sometimes they drag. Sometimes they lag, right? So hopefully you'll get the gist of it from these next 2 examples. First step is going to be subtracting x. Rewriting it in whatever form, like you want the x first or the y-intercept, or sorry, that's not the y-intercept, or the constant first. And then dividing, but like what? It's already done, right? In this case, because the y didn't have a number in front of it, I already have the slope-intercept form. The x-intercept would be if I had the equation. You can also solve for the x-intercept in this form, but for me it's like easier to just like scribble this out and then divide. So 2 goes into 6 3 times, right? And then the y-intercept, that's if I did 2x plus y equals 6, and I just scribbled out the x part. But it's also this guy right here. Slope is -2. And so at this point, because I'm asking you to figure out the intercepts and the slope, how you graph it is up to you. Practice what you need to practice. So I'm going to do slope intercept. So 1, 2, 3, 4, 5, 6. That's that guy right there. And then since the slope is -2, you'll go down 2 over 1, down 2 over 1, down 2 over 1. Maybe before you put those points, you can double check what your x-intercept is. The x-intercept is 3, 0. You know, we have it right there. And so then you could just see the pattern of the slope just fills in the other dots, the other points. Okay, last example I'll do with you. This 4 already had a negative, and then when I subtracted the x, that caused me to use the negative in front of the x. So this side has 2 negatives on it. And then when I divide by 2, this one is a little odd because there's no number here to divide, and the lower number does not divide evenly into the top number. So your slope is going to remain whatever this is in front of the x there. The x-intercept, x plus 2y equals -4. If I scribble that out, the x-intercept is -4. The y-intercept, when it's written in slope-intercept form, this cancels, leaves you with a y. This slope right here is -1/2 x. If you put x over 2, it means the same thing. Negative x over 2. And then this divide stays negative, and that's your y-intercept. This is a lot. We've talked about a lot. I did a lot with you when I was when I was with you, and then when we were gone, there's a lot on your shoulders there to try to come up with. So hopefully, having the list of Khan Academy is at least in terms of what